Yes, is this audible?
Yes.
Uh, So we had a revision class on the last class that we had Wednesday. All right. So we'll begin with electric flux today. This is the last part of your chapter, electric field and charges. Rest of the portions we have already covered. So see what is meant by electric flux. So we had done a concept of electric field lines, if you remember. What were electric field lines? Can anybody repeat? What was made by electric field lines?
Pictorial representation of electric field.
Yes, correct. Pictorial representation of electric field mainly. If you have electric field with you and you wish to represent it through diagrammatically or pictorially, then you can represent it through electric field line. So we had seen there were certain properties of electric field line. So electric field lines, for all those who don't know, these are continuous curves. These are continuous curves which are pictorial representation of electric fields basically. So there are various properties of electric field lines as well that we had studied. So now see what is meant by electric flux. If I give you a plane surface, for example, this is a plane surface that we have, and I tell you that there are 4 electric field lines passing through it. Now, if I say these electric field lines, these are perpendicular on the plane surface. These are perpendicular means what? Making an angle of 90 degree. So if this angle of 90 degree is made with the electric field line, between the electric field line and the plane that you have, then number of field lines that are crossing this area normally, you'll count them and that is considered as electric flux. So what is meant by electric flux? Electric flux is basically number of field lines that are crossing an area normally. Normally is the condition, means the electric field lines have to be perpendicular. All the electric field lines which are perpendicular to the plane surface, that will be considered only. So just tell me what will be the electric flux if you look at this figure that I've drawn.
4.
4. It will be 4. So you represent electric flux through this symbol, this phi symbol. So phi will be equal to 4. This is what is meant by electric flux. So I'll write down the definition also. Number of electric field lines crossing an area normally. So normally means perpendicularly. Now see, all the electric field lines cannot cross an area perpendicularly always. It may happen that electric field lines are inclined at some angle. So if I say, let's say this is the surface area that I have. This is a plain 2D sheet that I have taken. An electric field line is making some angle with the plane surface, which is not 90 degree. So will this electric field line be considered under flux? No, it
No.
won't be considered. It won't be considered. The condition says that all the electric field lines have to be normal. So what do? We take out the perpendicular of the plane surface, whatever we have. Like if you have this plane surface, you drop up the perpendicular to it automatically by yourself. This is the plane surface that you have. Let's say this is the plane surface that you have. Let's also specify the surface area. Let's say S is the surface area of it. This is the surface area of this 2D sheet that I have. Now see, I have drawn a perpendicular now. This is making an angle of 90 degree. this vector that I have drawn in. So you know this vector that is perpendicular to the surface of the sheet. Perpendicular means if electric field line was aligned in this manner, I could not consider this electric field line. So I had taken the perpendicular to it this way. This is known as area vector. This n cap that I have taken, this is known as area vector. So what is the direction of area vector? Direction of area vector is always perpendicular to the surface. So direction of this area vector is perpendicular to the surface. This is perpendicular to the surface. Now see, electric field is making some angle with the area vector. Let's say this angle is theta. Electric field line was making some angle with the plane surface as well. But we are not concerned with whatever angle electric field is making with the plane surface. We are concerned about this theta. What is this theta? Theta is the angle between electric field and the area vector. See, the theta that we are considering, this is not the angle that the electric field is making with the plane surface. No, this is the angle that it is making with the area vector. And what is meant by area vector? Area vector is basically a perpendicular dropped on the plane surface. Now see, if you have such a condition where electric field is directly not making an angle of 90 degree, how will you calculate flux, or what is the general formula for calculation of flux? So if you remember dot product, we have discussed cross product, I guess, in torque when we were discussing torque. Regarding the dot product, phi electric flux, which is this phi, this is equal to the dot product of electric field and the surface area. So whatever is the surface area of the surface, like it's a plain 2D rectangle, then you know how to calculate the surface area of a rectangle. Electric field is given to you. Angle is given between electric field and the area vector. So how do you expand dot product? You take the magnitude of the first quantity. So what is the first quantity? Electric field. You'll take the magnitude of electric field. You'll take the magnitude of surface area. And what function do we use? Do we use cos theta or sin theta when we are opening a dot product? Yes, Shavya?
Sin theta.
Sin theta. So what do you use when you are opening your cross products? We did torque. Torque was P cross E. PE sin theta. That was cross product. So in case of dot product, yes, Atif?
Cos theta.
Cos theta. All right. See, don't get confused. When you are considering cross product, the way we have did it for torque, in case of torque, which we did, that was P cross E, PE sin theta. Now what are we considering? We are considering dot product. So here you will consider cos theta. This is how you open the dot product if any quantity is given. Now let me just revise what all quantities are present. Phi is what? Phi is the electric flux. E is the electric field, S is the surface area, theta is the angle electric field is making with the area vector. If in any question you are given angle which the electric field is making with the plane surface, then do not consider that angle. Subtract it from 90 degree and check whatever is this angle. All right, so this is how you will calculate it. Now see, direction, regarding the direction of area vector. Okay, before that, can any one of you tell me what should be the SI unit of flux? Or all of you write me in the chat box. You know the SI unit of electric field now, you know the SI unit of surface area now. So if you multiply, take the product of the electric field's SI unit and surface area, what should be the SI unit of electric flux? So yes, only Memuna has answered. All of you know the SI unit of electric field by now. Okay, Mariam is right, Atif is right. Yes, Khalid. It will be Newton meter square per coulomb. See, for electric field, we know the SI unit. Electric field is what? If you remember, we established a relationship between force and electric field. So, electric field was force by charge. It means the SI unit of electric field is what? Newton per coulomb. And surface area is what? Meter square. So, the SI unit of it will become Newton coulomb inverse meter square. This will be the SI unit of electric flux. Now see, if you remember, I have told you once that the SI unit of electric field is not only Newton per coulomb. In the next chapter, we'll be discussing electric field's SI unit is voltmeter also, volt per meter. Volt divided by meter when we'll be studying voltage. So another unit becomes volt meter. This is also the SI unit of electric flux. So majorly you can use any of the SI units that are available. Also, you are not required to consider whatever is the direction of electric flux because this is a scalar quantity. It has a specific direction. How we have to consider it positive or negative, that I'll tell you. So it's a scalar quantity. So unlike electric field and forces, where we had to take all the directions, we are not required to take out the directions. One more thing, if I give you this plane surface, if I say this is a rectangular sheet that you have, if you draw various number of area vectors, like if I say I have drawn it over here, I have drawn area vector over here, I have drawn the area vector over here. So any area vector or any field line that is just perpendicular to it, that is considered as area vector. So you are not required to take the area vector in the center only. You can take the area vector anywhere. Reason is that because whatever you take, that will be perpendicular to it only. That is the definition of area vector that we have. So direction of area vector will be same for all of them. This will be 90-degree, this will be 90 degrees, this will be 90 degrees. So direction of area vector for a plane surface, that will be same. So you can take any area vector. It's just that it should be perpendicular to the surface. And since it is perpendicular to the surface, it will have the same direction. So direction of area vector for a plane surface. For a plane surface is same at every point. All right, is this clear to all of you? Concept of electric flux and the basic formula of it. Just note it down. All right. Okay, Salman, you can leave. Just come whenever you're free. No, Maimuna. Weber is the SI unit of magnetic flux. So we'll be studying in magnetism. You have two kinds of flux with you. One is your electric flux, where electric field lines are considered. The similar concept you have in case of magnetism. There you will be having magnetic field lines instead of electric field lines. So there the SI unit will be Weber. All right.
Okay, teacher.
Yes, written.
Last point.
Just let me know when you all have written.
Done, ma'am.
All right. Now see, this was regarding a plane surface that we had. So we don't have only the plane surfaces, we have curved surfaces with us as well. No. So what will be the case if we have a curved surface? For the calculation of curved surfaces. So basically curved surfaces are what? Spheres, hemispheres, cones, cylinders. So in case of cones and cylinders, we have two kinds of surfaces. No, one is the flat surface, other one is the cone that it is making. That is the curved surface. In case of cylinders, also you have three surfaces. Two are the flat surfaces, other one is the curved surfaces. So what will happen if the electric field lines are crossing or passing through that curved surface? So how will you calculate it? So first thing that will be the same as that, let's say this is some part of a sphere and electric field lines are crossing this. Let's say some electric field lines are crossing it. So these electric field lines are not perpendicular to the surface. So what do we need to do? The first step,
Draw an area vector.
draw the area vector. Correct. So how do we draw the area vector? We just drop a perpendicular. So let's say this is the surface and the perpendicular to it will be somewhat like this. So this will be the electric field, this will be the area vector, and this is the angle theta that we'll be considering. Now see, in case of curved surfaces, what do? We take a very small element. Instead of taking the whole surface area S as S, we take a very small surface area, let's say ds. So ds is the very small surface area, small area element. So in case of curved surfaces, what do? Instead of writing this d phi, the way we have been doing, d phi is equal to E dot S. What, instead of taking phi is equal to E dot S, here we have the very small segment d phi, ds with us. So phi will also be d phi. So how to solve this? D phi is equal to E dot ds. You have a very small quantity with you, a very small element with you. Now you have to expand this. Integration you do. So if you'll do integration of it, this will be E dot ds, complete integration of it. So the final formula that you get in case of this closed surfaces, this phi will be equal to what? Closed surface integral of E dot ds. So this is similar to all the integration that you have done. All the rules of integration will be valid over here. So this is how you take out. This is the surface integral. This is the surface integral. And you can also write it in this manner. E dot ds along with this closed symbol. This represents that it's a closed surface. For closed surfaces like spheres that you have, cube that you have, all the closed surfaces, you can consider in write in this manner. This shows that it is a closed surface. So let's do some questions on it only. Then it will get clearer. Do one thing, just note down these 2 points for curved surfaces. Let's do some questions on this. We'll do some practice on this formula based question. All right, just note it down first. So, have you all written the notes that of the closed surface, this upper part above the question? No, Shravya, just check. Once again, check your answer. Let's discuss this question then if you all have written. See, what does it say? It says electric field 10 Newton per coulomb exists in space. You have to calculate the flux through an area of 5 meters square, which is given in XY plane. The field lines are inclined at 60 degree with what? With the plane of the area. All right. Now see, this is your electric field. Let's say this is the area that it is talking about. So electric field is inclined at 60 degree with this plane. Means let's say if this is, let's draw up an axis. So this is 60 degree. This is given to you as 60 degrees. Now it's correct, Shravya. Now it's correct. This is the correct answer. All right. So you have to consider, you have to calculate whatever is the flux. So yes, Salman, what is the formula of flux that we have studied? Yes, Salman, we have done it a few minutes back. Just look into your notes and see what is the formula of flux. Yes, Salman, are you able to hear? All right, Samaira, you tell.
ES cos theta.
ES cos theta, correct. Dot product of E dot S. Means E dot S we have to consider, which can be written as ES cos theta. Correct. So, Sarah, tell me what is E given? What should I write for E?
10.
10. Correct. E electric field is given as 10 Newton per coulomb. Okay, Salman, it's okay. Is it audible to you now? Your network issues, just fix it. So, okay, yes, Sarah was correct. Electric field will be what? 10 Newton per coulomb. All right. What is the surface area that I'll be taking, Shravya?
5 meters square.
5 meters square. Correct. So, S will be 5. Why? Because it is given area is 5 meters square. So, this will be 5 meters square multiplied by cos theta. So yes, Khalid, what is theta that I should put? Yes, Khalid. Hania, you tell.
Cos 60 degrees.
Cos 60 degrees. Okay, Hani, tell me what is this theta that we take in the formula? Angle between what?
Angle between the electric field and the area vector.
Area vector. So 60 degree, is it the angle between electric field and the area vector?
No.
No. So first what we'll do, we'll drop an area vector. All right. Now see, we cannot consider this electric field because the condition says that it has to be normal. So what we'll do, we'll drop an area vector. Now tell me, area vector is perpendicular to it, means this hole is making an angle of 90 degree. This part is 60 degrees. Now Hania, tell me what will be theta? See, this hole is 90 degree because area vector is perpendicular. This part, inclination of electric field with the plane, this is given as 60 degrees. What will be? If this total, see, Hania, see, this hole is 90 degrees. If I say I have taken 60 degrees from it, how much is left?
30 degrees.
30 degrees. So yes, Memuna and Sara are also correct. It will be 30 degrees. No, see, the whole angle is 90 degree. Why? Because area vector makes an angle of 90 degree with the plane surface. That's why I was telling you to be careful with the definition of this theta. Many a times you'll be provided by this angle only, that the electric field will be making with the plane surface. But we don't require that angle. We require the angle between electric field and area vector. So between electric field and area vector, we can calculate in this manner. So from here, you can easily see this angle. This will be 30 degrees. So instead of putting cos 60 degrees, you have to consider cos 30 degree. Is this fine?
Yes,
Now
ma'am.
see, we just have to multiply 5. This will be 50. Third, this will be 3 root 3 divided by 2. So 5 will be what? This will be 25 root 3. And Newton, Coulomb inverse, meters square. This will be your answer. Just note down the solution. We'll do more questions on this. All right. So see, it says that electric field is I cap plus 2j cap plus 3k cap. And area vector is given to you as surface area. This S is basically the surface area. So this is I cap minus J cap plus K cap. So we have to calculate the flux, and the formula of flux is what? E dot S. So we have to take the dot product of both these. So let's put the value for electric field. What do you have? Instead of electric field, I can write as I cap plus 2J cap plus 3K cap. This is what? This is electric field. Dot the surface area. Surface area is what? I cap minus J cap plus K cap. This is E dot S. This is we have to just solve it now. Now see how to solve these kinds of values when it is given in terms of the unit vectors that you have. So just take the coefficient of the first one, the vector I cap. What is the coefficient of this I cap?
1.
1.
1.
It is 1. So see, 1 is the coefficient of I cap from here, and whatever same is 1 is the coefficient of I cap from here as well. So 1 multiplied by 1. Basically, what are we doing? We are multiplying 1 I cap with dot 1 I cap. So 1 into 1 will give us 1, and I dot I or J dot J cap or K cap dot K cap, this is always equal to 1. So when you will multiply 1 I cap with 1 I cap, you will get 1 only. So we have 1. We have solved this I cap part. Now the coefficient of J cap is 2. What is the coefficient of J cap from here?
1.
Yes, Shavya?
1.
Not 1.
Negative 1.
Negative 1. It will be minus 1. When you are taking the coefficient, you have to consider the sign. So now see what are we doing? We are taking 2J cap dot minus 1 I cap. 2J cap minus 1 I cap. So J dot J is automatically 1. So that J will be eliminated itself. 2 multiplied by minus 1 is what? Minus 2. So you have minus 2. Now 1 came from I dot multiplied by I cap. Now 2 you have from 2J cap minus J cap. Now see what do we have? We have 3K cap with multiplied with K cap. So K cap will be 1 only, because K cap dot K cap is 1. So just take the coefficient and multiply them. 3 is the coefficient of K cap from here. 1 is the coefficient of K cap from here. 3 multiplied by 1 gives you 3 only. So you have positive 3. Did you understand this? Since I cap dot I cap or J cap dot J cap or K cap dot K cap is always equal to 1. How to solve these? We just take the coefficients of I cap or J cap that you have. Multiply the coefficients of I cap with I cap's coefficient from the other quantity. Then take the coefficient from J cap and multiply it with the quantity of J cap. Similarly, do it for K cap. Now, 1 minus 2 plus 3 you have as 2 Newton Coulomb per meter square. Is this clear now? All of you?
Yes.
Yes, ma'am.
Atif, Hania, Khalid, Samaira. Is it clear?
Yes, ma'am, it's clear.
Just note it down. We'll do one question similar to it that you all will answer. So let me write down the question. Yes, Hania.
Can you please explain again?
Let me repeat it once more. See, electric field is given to you as what? I cap plus 2J cap plus 3K cap. Surface area is given to you as I cap minus J cap plus K cap. You have to calculate electric flux. How do we calculate electric flux? We take the dot product. So electric field dot surface area means this quantity dot surface area is this part only. So I hope it will be clear till here, because we have just put in the values here. Now how to solve this? I cap, you will multiply all the like vectors together. Means you have to multiply all the quantities with I cap together, all the quantities with J cap together, all the quantities with K cap together. So what do? Take the first, your vector that you have electric field, take the I cap's value that you have. Means one I cap you have from electric field. You have one I cap from surface area. If you will multiply one I cap with one I cap will be 1 and 1 into 1 will be 1. So all the time you will be multiplying I cap with I cap, J cap with J cap, K cap with K cap. You will be getting 1 only. So how do we calculate? We just take the coefficient of the like terms and multiply. If 1 is the coefficient of I cap from electric field and 1 is the coefficient of I cap from surface area as well, 1 multiplied by 1 will give you 1. That's why I have written this one. Now coefficient of J cap from electric field multiplied with the coefficient of J cap from surface area. So coefficient of J cap from electric field is 2 and coefficient of J cap from surface area is -1. Multiply 2 multiplied by -1 gives you what? -2. So that's why I've written -2. Then take the coefficient of electric field of K cap. So 3 is the coefficient of K cap from electric field. Now you have to take the coefficient of K cap from the next vector that you have, that is the surface area. So that is what? That is 1. So 3 multiplied by 1 gives us what? 3. So I have written 3. So 1 minus 2 gives -1 and 3 minus 1 gives 2. Is it fine, Hania, now?
Yes, ma'am. Thank you.
So till the time you people are writing, I'm giving one more question similar to this one. All of you will answer that. So all those who will be getting the answer, just keep on sending me. So see, this is the question. All of you try it once. Electric field is given to you, I cap plus 2j cap plus 3k cap. Flux you have to calculate through the area 5 meter square. Now the unit vector of area is not given to you. It has just specified the magnitude 5 meter square. So now it's your duty to calculate which unit vector will come. We always consider the area vector. So if xy plane is given to you, just check up. If xy plane is given to you, what will be the perpendicular to it? Means what will be the area vector to it? If whatever area vector you are getting in whichever axis, that will give you the unit vector. So it might be 5i cap, 5j cap, 5k cap. You just have to check which unit vector will come with area, and then you have to solve it similar to the way we have done the previous question. So all of you tried and said me. No, Shravya. Just check once again. Rest of you also submit your answers.
Sorry, ma'am, I took the wrong value.
Okay,
Instead of
just
3K, I took 5K.
all right. Resend then answer. Just do your calculations once again and send. Till the time, rest of you also submit your answers. Atif, Hania, Khalid, Memuna, Salman, Samaira, Sara.
Yes, ma'am.
Yes, Shravya, now it's correct. No, Memuna. Just do your calculations once again and check. Hania, you also check your answer once again. Okay, let's discuss it now. So only Shravya has given the correct answer. See, it says electric field is given to you. Electric field is what? I cap plus 2 J cap plus 3 K cap Newton per coulomb. This is the electric field that you have. We have the area's magnitude only. We don't know what is the unit vector because it has not provided to us. In the previous question, what did we see? Area vector was given in terms of unit vector only, I cap plus j cap and k cap in terms of that. Now the surface area is what? Surface area is given as 5 meters square only. So we have to consider what will be the unit vector from ourselves. It has given us in xy plane. So xy plane means the plane that is made between the x and y axis. If this is the y axis, this is the x axis, this is the x axis, this is the y axis, then this plane that we get, this is known as the xy plane. No, Khalid, you also check your calculations once again. See, x-axis is this, y-axis is this. So this plane, this part, this is known as xy plane. If I give you different axes, let's say x-axis and z-axis. x-axis with z-axis. This outward is your z-axis, this is your x-axis. So this part, this plane that it is making, this will be xz plane. Similarly, if you have z-axis and if you have y-axis, so this plane that you have is the zy plane. Similarly, plane between x-axis and y-axis, this plane becomes the xy plane. So I hope the planes are clear. So xy plane is what? The plane made between the x-axis and the y-axis. Now see, when we are taking out flux, or whenever we are doing the calculations of flux, we take the area vector. So you all only tell me, if this is your plane surface, what will be the area vector to it? What will be perpendicular to it?
Z-axis.
Z-axis. Z-axis will only be perpendicular. See, x is this, y is this. What is perpendicular to x and y? The z-axis. Z-axis is only perpendicular, no? So positive x is given or positive y is given, you have to consider what? This is the plane surface. Now you are dropping a perpendicular to it, dropping a perpendicular to this plane surface that will point in the z-axis. And yes, Hania, you tell me what is the unit vector that we use for z-axis?
K cap.
K cap. So it will be 5 K cap meter square. Now we can calculate the answers. Is it clear till here to all of you? All those who were committing errors and all those who were not able to answer. Is this clear now? 5 K cap. Any doubt in this? Is this clear to all of you? Khalid, Memuna, Hania, 5 K cap.
Yes, ma'am.
All right. Now see, you know how to solve this. Phi is what? Phi is E dot S. So electric field is what? I cap plus 2J cap plus 3K cap. This is electric field part. Dot. Now we have the vector surface area with us as 5K cap. Now see, we will be calculating similarly to the way we have done it for the previous question, the above question. Take the coefficient. So yes, coefficient, Salman, you tell me, is this audible to you, Salman, now? If it's audible, then unmute yourself.
Ma'am, I can't hear it properly. My internet is very bad.
Okay, it's okay, Salman. So if you want me any part to repeat, just let me know. Wherever your internet got stuck, just let me know, I'll repeat it for you. All right?
No, sir. No, ma'am. I understood.
Okay. All right. Fine. All right. So yes, Atif, tell me, what is the coefficient of I cap from the electric field vector, this quantity?
0.
Coefficient of I cap is 0. You have I cap with you.
So for E or for S?
For electric field, from electric field,
Electric field, it's 1.
and from surface area?
0.
0, correct. So see, since you don't have I cap with you, what will be the coefficient of I cap? It will be 0. So how do we solve it? We multiply both the coefficients of I cap from one quantity and the other quantity. So from electric field, you have the quantities, that is I cap coefficient as 1. From the surface area, you don't have I cap with you, so you have 0. 1 multiplied by 0 gives you what? 0. Then you have to take 2 J cap. The coefficient of J cap. What is the coefficient of J cap from electric field?
2.
2.
Yes, 2, and there is no J cap in the surface area. It means 0. Again, 2 multiplied by 0 will give you 0 only. Then what do you have? You have 3K cap multiplied by 5K cap. So here you have the coefficient as 3 and 5. So if you multiply 3 and 5, yes, Memuna, now it's correct. It will be 15. So final answer, 15 plus 0 is 15. You can write the SI unit as voltmeter or Newton per coulomb meter square. Is this clear now? Whenever you are given the planes, just drop the perpendicular and see wherever is the direction of area vector. Wherever the area vector is leading to, you take the unit vector of that axis and then solve using your dot product. So just write it down. Done?
Yes, ma'am.
So see, you can have different figures with you. So what the thing you have to consider is the surface integral. You have to consider the surface integral with you. For example, if you have a sphere with you, let's say the sphere is there with the radius r. So what will be the surface area? The surface area of a sphere is what? R is the radius given to you. Capital R is the radius given to you of the sphere. Then what will be the surface area of a sphere?
Could you repeat your question?
4 pi r square.
Yes, Khalid?
4 pi r square.
Correct. 4 pi r square. From your basic mathematics, you all know. So if sphere is given to you, capital R is the radius, it will be 4 pi capital R square. So the surface area integral that you will be considering, you will be putting 4 pi R square by yourself only. Or if you have another figure, let's just take an example of cylinder with you. L is the length of the cylinder and small r is the radius of the cylinder. So you will be considering a very small element again. Here also we considered the very small element. This was ds. Here also you will be consider this ds with you. So what will be the value of ds for this cylinder now? If length is given to you, r is given. It is 2 pi rl. 2 pi rl is the curved surface area. So you will be considering 2 pi rl by yourself only. So if you have questions with you in this manner, if you are given questions in this manner, the question says you have to, or let's say a charge capital Q, this is placed at the center of a sphere. At the center of a sphere. Is placed at the center of a sphere. You have to calculate the flux through it. Calculate the flux through it. So see, how will you solve these kinds of questions? If let's say this is the sphere that we have, and plus capital Q is placed at the center, and let's say capital R is the radius of it. So capital R is the radius of the sphere. Radius of the sphere. Now what you'll do, if I say this is the electric field is perpendicular to the surface. I have given you this condition. Also, this question is a kind of derivation for you also. I am doing it in the form of question. So this is an important one. So what is the angle that the electric field is making with the area vector now?
0 degree.
0 degrees. Because see, area vector is also making an angle of 90 degree. If you'll draw the area vector, it will be this. So both of them are parallel. It means electric field is making 0 degree with the area vector that you have. So phi is what? Phi is closed integral of E dot ds. That's what we have seen. Even if you open this, E ds cos theta, theta is what? Theta is 0 degrees. So cos 0, this will be 1. So phi will be closed integral of E ds. Now, all of you write me in the chat box right now, what is the value of electric field, or what is the formula of electric field for a sphere? We have done it. Electric field's value for a point charge or sphere is same. Electric field's value for a sphere, write down. We have done this. The general formula of electric field. Yes, Atish, Shravya, both are correct. All of you respond. This is the basic formula for electric field. Without this, you won't be able to solve any question of electric field. Yes, Khalid, you tell me, what is the electric field for a point charge or a sphere? Yes, Maimuna, that is F by Q naught. So what will be the value if you put, yes, Salman, it will be KQ divided by R square, F by Q. So when you'll put the value of F as KQ1 means KQ square divided by R square, then you will be left with KQ divided by R square only. See, we had done this a long time back before your vacations. Electric field for a point charge. Electric field for a point charge is K capital Q divided by R square. If you remember, we had derived a relationship between electric field and force. Electric field was what? Force divided by charge. Force was KQ square by R square. So one Q got eliminated, that was the test charge. So the formula of electric field is K capital Q divided by R square. This is the formula of electric field for a point charge. K is what? K is the constant that is written as 1 over 4 pi epsilon naught R square. This is the formula of electric field for a point charge or a sphere. So electric field we have. Regarding ds, as I've told you just now, and the way Khalid had answered, it will be 4 pi capital R square. Now we have electric field with us. Now we have ds with us. Let us put the values of electric field and ds. So flux will be what? Electric field is Q divided by 4 pi epsilon naught R square multiplied by 4 pi capital R square. If you look up from here, 4 pi will get cancelled and your R square will also get cancelled. So from here, phi will be equal to what? Q divided by epsilon naught. First of all, tell me, is it clear till here to all of you?
Yes, ma'am.
All right. Now see, this is an important relation. This Q by epsilon naught that we are getting, this can be given through a very important law that is known as Gauss law, Gauss theorem or Gauss law. So see what is meant by this Gauss theorem. This is an important relation. Phi is equal to Q by epsilon naught. So it's a kind of derivation that we have done this question. So see what is meant by Gauss law is this. If you have any system with you and the charge present on the system is plus Q. So Gauss's law says that phi means electric flux, that is E dot ds. This will be what? This will be equal to the result that we have drawn just now. This will be equal to Q divided by epsilon naught. This was the result that we had drawn, Q by epsilon naught. In this question, the resultant was coming what? Phi was coming as Q by epsilon naught. So your phi is Q divided by epsilon naught. So what is meant by Gauss law? Gauss law says that according to Gauss's law, it says that the flux, this phi is what? Phi is electric flux. It says that the electric flux through a closed surface, this is essential, through a closed surface. Through a closed surface. So you have to consider the charges that are present within the surface only. You don't have to take the charges outside the system. Take the charges from an open system. Whatever charges are residing or enclosing, that you have to consider. So according to Gauss law, electric flux through a closed surface is what? It is 1 over epsilon naught times 1 over epsilon naught is getting multiplied by what? The charge. So it says that the total flux through a closed surface is 1 by epsilon naught times the total charge enclosed by the surface. This is the statement of Gauss law that you all have to remember, and the above part is the derivation of it. So see, Gauss law says what? Phi is Q by epsilon naught. So just define it in terms of your words only. Phi is equal to Q by epsilon naught is your Gauss theorem. So it says phi, that is electric flux through a closed surface, is 1 over 4 pi epsilon naught times multiplied by the charge enclosed. So you have to consider all the charges that are enclosed within the system only. It has certain properties through which it will get clearer. Till the time, note the question, note these points, and we'll do some properties of Gauss law. From here, then it will be clear.
Ma'am, could you scroll down?
Let's see what are the properties of Gauss law. So the first property says that if I take a small sphere, let's say the radius is capital R and the charge is plus q, or if I take a bigger sphere with the radius as 2r, means twice the radius, and the charge that I have enclosed is plus q, or I have taken a cylindrical surface and charge is plus q, or take any system with you, this random system with you, and the total charge enclosed in the system is plus q. What will be the flux over here? Flux is charge enclosed by epsilon naught, so flux will be q by epsilon naught. Flux here will also be q by epsilon naught. Here also it will be q by epsilon naught, and here it will also be q by epsilon naught. So what does it say? It means that electric flux is independent of the shape and size of the body. You are concerned with the charge. and epsilon naught is the constant which you all are already aware of. So this says that flux is independent of the shape and size. Shape and size of the surface. And size of the surface. So you are considered with what? You are concerned with the charge. Whatever charge enclosed is there, that will be considered for the calculation of electric flux. So charges, what about the charges that are outside? If I say this is a system that I have, minus Q2 is there, plus Q1 is there, plus Q3, these are some of the charges over here. Q4 is there, minus Q5. This is the system that I have. So only the charges that are enclosed within the system will be considered. So your Q enclosed, you will be taking Q1 minus Q2 plus Q3. You won't be considering Q4 and Q5 because these are lying outside the system. You are concerned with the charges that are enclosed within the system. So flux will be what? Q enclosed divided by epsilon naught. That will be Q1 minus Q2 plus Q3 divided by epsilon naught. This is how you take. And also, as I've told you, electric flux is a scalar quantity. It means it has no direction itself. So how do you consider if it's a positive flux or if it's a negative flux? Because you are not able to calculate the direction since it's a scalar quantity. So remember, if you have a system, let's say this is a system plus Q is the charge. Flux is outwards. For a positive charge, electric field lines will be moving away from the charge. That we have seen. The property of electric field line is what? It begins from positive charge and terminates in the negative charge. Means electric field lines are directed away from the positive charge and directed towards for negative charge. So if you have a system where the flux is outwards, so outward flux, this is considered as positive. Whereas if you have this system with you, minus Q is there, all the electric field lines will be coming to minus Q because this is the property of negative charges. So this will be what? This will be inward. This will be inward flux, inwards flux. So inwards flux are always considered as negative. What is meant by positive and negative? It's that electric flux, this will be plus Q divided by epsilon naught. It will be negative. So here it will be minus Q divided by epsilon. All right. So since it's a scalar quantity, you will be considering whatever are the directions for it. Now see, if electric field lines just cross the surface. Okay, Hania, you join us. Till the time we are just discussing the basic properties that you will be able to understand. Come back. See, if you have the surface with you, let's say this is the surface that you have. What if the electric field lines is just crossing the surface? Electric field lines are just passing by the surface. Means no electric field line is entering the surface. No electric field line is entering the surface. It is just passing by it. So see, what will happen is there electric field lines are passing by the surface. So if this is your surface, electric field lines are also on this surface, just crossing it. So if you take the area vector with you, area vector will be perpendicular. So what will be the angle between electric field and area vector? Angle, yes, Shavya, try.
Ma'am, could you repeat again?
See, electric field lines are just crossing the surface area. This is the condition I have given it to you. They are just crossing the surface area. So what will be the angle between electric field and area vector?
0.
No, you were correct initially.
90.
90 degrees. No, it will be 90 degrees because electric field is now in the same plane with the whatever is the surface with you. Area vector will be perpendicular. So angle between electric field and area vector is the angle between the plane surface and area vector, which is always 90 degree. So here your theta becomes 90 degree. Cos 90 is what? Cos 90 is 0. So flux will be 0. So if the electric field lines, these are crossing a closed surface, then your flux is 0, because firstly the field lines are not entering the surface, so there is no field line, so your flux will be 0. Mathematically you can say that theta is 90 degree. If angle is 90 degree, it will be cos 90 will be 0. One more property is that if you have a set of dipole, let's say this is the system that I have, minus q plus q. All of you should remember we have discussed dipole in the last class as well. Dipole is a set of positive and negative charge with the same magnitude and opposite direction. So this forms your dipole. So in case of dipole, what will happen? The charge enclosed, this is what? Minus q plus q. And always it will be minus q plus q for a dipole, because this is what? This is the dipole. So your charge enclosed will always be 0. If your charge enclosed is 0, flux will be what? Flux will also be 0. So for a set of dipole, electric flux will be 0 if you have a set of dipole. So these are very easy basic properties of Gauss theorem. Let's do some questions on it. Till the time, just note down the properties of it. If you have any doubts regarding the properties or any doubt, you can ask me. By now you must have written it. Yes or no? Still writing? Just let me know when you have written it. All right, now by now all of you must have written all the properties. So any doubts in the properties?
No.
All right, now let's solve this question. It says that a charge Q has been placed in the center of a cube. So if it's a positive charge, then obviously we know this will be the direction of electric field lines away from the charge. It says calculate flux through the cube. Cube is what? Cube is itself a closed surface. A charge is residing within the closed surface. So what is the electric flux? Do we even need to calculate it? What will be the electric flux? The electric flux will be charge enclosed multiplied by 1 by epsilon naught. Means Q is the charge enclosed divided by epsilon naught. This will be the flux through the cube. Yes or no? This is what was Gauss theorem? Yes?
Yes, ma'am.
Is it clear to all of you? Do all of you agree with the first part?
Yes.
Yes.
All right. So see, it then says flux through each phase. It means, what did we do? We had seen that flux through cube. Yes, Shravya, right, correct answer. See, flux through the cube is what? Flux through the cube is Q by epsilon naught times. How many faces are there in a cube? There are 6 faces in a cube. It means if I say flux through a single cube is Q by epsilon naught time. This means that flux through 6 faces is also Q by epsilon naught times. A single cube, if I say a single cube has 6 faces, so whatever will be the properties of a single cube will be the properties for the 6 faces. Do we need to calculate the electric flux through the 6 faces? We require to calculate it through one phase only. So flux through one phase, it will be what? Simple unitary method, Q by epsilon naught divided by 6. So this becomes Q divided by 6 epsilon naught. Flux through cube is Q by epsilon naught. Means flux through 6 phases is Q by epsilon naught. So flux through single phase will be what? Q by 6 epsilon naught. I'm giving you one more question similar to it. Just note down the first part and all of you will answer me the second part, the question that I'm writing. If you have understood this first part, then you should be able to answer the second part by yourself. Note down this part, all those who have not written, and I'll give you another question. If you have understood this first question, you should be able to answer the second question.
Ma'am, could you scroll down?
So this is the second question. Do try it yourself. Similar, it is similar to the one that I have given it through the cube. Now this shape has been changed. Instead of the cube, you have the hemisphere with you. So send me your answer. What will be the flux through it? What will be the flux through the hemisphere? Send me your answer. And your calculation should not take a lot of time because you are not involved with numerical values in this. So Shravya has given her answer. Rest of you also give your answers. Okay, so many of you have answered. So correct answers have been given by Salman, Khalid, and Mamuna. I'll let you know how we do. But Mamuna, can you explain how did you calculate? Yes, Mamuna.
Ma'am, first I did was the Gauss's law for the hemisphere. I wrote as phi is equals to q by E naught. Then I wrote flux passing through the hemisphere. I wrote 5 by 2. Then I wrote q, which will be equal to q by 2 E naught.
Why 5 by 2? Where this
Which
2 came?
because hemisphere, no, it's half of the circle.
Correct. I'll help you. Others, I'll help you with it. Memorize, right? See, what you are given, you are provided with a hemisphere. If I say this is the hemisphere that you have, let's say this is the hemisphere, and plus q is over here. So is this a closed surface? Means is q residing in this hemisphere? It is placed at the center of the hemisphere, means in this manner. Gauss law is valid for the charge that is inside the surface, means which is enclosed in it. We do not know, we know that this charge is lying, it is placed on it. We do not know that it is inside it. So we have to consider the charge that is placed on the top of it. All right. It is a closed surface, Shravya. Hemisphere is a closed surface, but the charge, when it is placed at the center of hemisphere, then we say the charge is not placed in the inside of the hemisphere. No, hemisphere is itself a closed surface. But if you keep the charge on the top of the hemisphere, then your charge is not within the closed surface. Hemisphere is a closed surface. So see, the solution to it is, we can at least complete the sphere if you put another hemisphere. Add one more hemisphere. If you add one more hemisphere, then will you get a complete sphere?
Yes.
So if you had this one hemisphere, you have added one more hemisphere. This makes a complete sphere. Now the charge is residing inside this closed surface. And what is the flux within a closed surface? Flux
By epsilon.
q by epsilon naught. So flux through the sphere is q by epsilon naught. So all of you who have answered q by epsilon naught, you have answered it for the complete sphere. Now it asked you to calculate it for the hemisphere. So flux through a single sphere is q by epsilon naught. Means flux through two hemispheres is q by epsilon naught. Flux through two hemispheres is q by epsilon naught, because two hemispheres make up your single sphere. So flux through a single hemisphere will be q divided by 2 epsilon. Just note down this. Yes, Shravya. So if your charge is not enclosed within the surface and no charge is enclosing in the surface, so your flux will directly be zero. It doesn't matter how many charges are present outside the surface. Even if your charge enclosed within the surface is coming out to be zero, then your electric flux will be zero. So let me explain you the question along only. A cube is given to you. This is kept in the x-axis in this manner. So this much distance is A. These are the faces of it, and the length means the side of the cube is also A. All right. Now electric field is given to you as alpha x to the power half. X is the variable that we will see how we do. So electric field exists along x-axis. It means you have all the electric field lines towards the x-axis only. No electric field line is there in the y-axis. Electric field lines along the x-axis. You have to calculate the flux through the cube and also the charge enclosed. And also the charge enclosed. Now see, if you look in this, electric field lines are directed along the x-axis. The question has specified. Means this is the direction of electric field lines. So let us consider one by one all the surfaces. This is the front surface that you have. Electric field is directed in this manner. If you take the area vector for the front surface, it will be in this manner, coming outwards. So will there be any flux existing for this surface, this anterior surface?
No, ma'am.
No, we have seen the property that if electric field is making an angle of 90 degrees, then your flux is 0. Means no flux is through this face. What about the back face? Similarly, electric field in this manner, back face is this, again 90 degrees, so 0. What about the top face? This is the top face. See, if you take the area vector for the top face, this will be n cap. Electric field is directed towards the x-axis. Again, area vector electric field making an angle of 90 degrees. So from the top surface, you don't have any electric flux with you. What about this bottom surface? If you drop an area vector n cap, electric field, this will be directed downwards. Electric field is directed in the x-axis. So again 90 degrees. Means there are no electric field lines for these surfaces. What about this surface, this left surface and right surface? N cap will be directed in this direction. So there is angle of 0 degree. It means electric flux will exist. What about this left face? This will be n cap, means it is making an angle of 180 degree. So electric field will exist. So you have to calculate electric field for left surface and right surface. For all the rest of the 4 faces, electric flux is 0. Is it clear?
Yes.
All right. Now see, what do? We should just take out the flux for the right hand side, then we have to take out the flux for the left hand side face. We can add it and we'll get the total flux through the cube. So see, flux for the right face, if we calculate, it will be electric field for the right face multiplied by the surface area. See, surface area will be what? Surface area will be A square. We are not considering the surface area of the cube. Remember, we are now calculating the electric flux for this right side face only. So where n cap is the perpendicular area vector, electric field is directed along the x-axis. All right, we are just calculating it through this face only, ER. So surface area's direction means area vector. What is the direction of area vector? I cap. X-axis, no, for the right hand side face. So you have the surface area with you. Now regarding the electric field is alpha x to the power half I cap. Now we have to put in the values of x. So see, for the values of x, see, just see the separation from the origin. This is A, this is A, this is A. What is the total separation of right hand side? 2A. Is it clear to all of you how we have got 2A?
Can you explain?
Yes, teacher.
Okay. Samaira, see. For this is the right hand side phase. We are calculating flux for this phase only. This phase only. X is any variable. That X is the variable means this is the distance through which the origin is placed, means the separation between the phase and the origin. So X is variable, it is given in variable form. So for different phases, you will be putting different values of X. For this right hand side phase, this phase, what is the separation from the origin? Samaira, you only tell me. This cube has been separated by a distance from origin, and this is also a. So what is the total distance from origin, Samaira?
2A.
2a. So that's we have taken 2a. See, we know the value of it with us. So electric field will be what? Alpha 2a to the power half I cap. Why? Because x is equal to 2a for the right hand side phase. For r, x is equal to 2a. So E is what? Alpha, this becomes alpha root 2 a I cap. This is electric field. So what will be phi r? Phi r will be alpha root 2a to the power half. You can write it in this manner, I cap dot. This is electric field. From here, this can be written as alpha root 2 a to the power half I cap. A to the power half. Now we have to write the surface area. Surface area is what? A square I cap. This is A square I cap. This is electric field, E. This is surface area. How do we write flux? E dot S. That's what I've written. Electric field. Electric field is calculated through the formula that it is given in the question, alpha x to the power half. It is variable electric field. For different distance, you have different electric fields. For A, you will be having different electric fields. As you will be changing the values of x, you will get different electric fields. So for right hand side phase, we have seen that x will be equal to 2a. So electric field will be this. Surface area is already a square I cap. So flux will be this electric field multiplied by the surface area. So a to the power half multiplied by a square. This will be what? This will be phi r. If you take this is alpha will be the constant. This will be 5 by 2. This will be 3 by 2. A to the power half. This is root 2 a to the power half. You will be multiplying this. I cap will be 0. So it's simply multiplied with a square. This will be what? This will be alpha root 2 a to the power 3 by 2. Is it clear for the right hand side phase? 3 by 2, alpha root 2 a to the power 3 by 2. Now see, this is for the right hand side phase. No, now we have to calculate it for the left hand side phase. This is for the left hand side phase. Shravya?
No, ma'am, I just gave the answer for left hand phase.
Okay, for the left hand phase, minus alpha root 2a to the power 3 by 2. Yes, it is correct. That will, so just take out Shravya, what will be the resultant, because for rest of the phases, top, bottom, electric flux is 0. Right hand side we have seen. For the left hand side, just see. So electric flux for the left phase. So we have to see electric field for the left hand side phase. So Samaira, just look at the left hand side phase. Now tell me what will be X? Yes, Samaira. This is the left hand side phase that you have. This is the origin. What is the separation of the phase from the origin?
A.
A. So X will be A for this case. So electric flux will be what for the left case? Alpha x to the power half, it was there. So now it will be simply A to the power half. A to the power half. Now one more thing. For the left hand side face, this is the left face that we have. N cap will be directed here. Perpendicular will be in this manner only. Outside the cube, it will go in this manner. This way. Electric field is directed where? Electric field is directed in this manner. So what is the angle now? Now the angle is not 0 degree. Now the angle is 180 degrees. 180 degrees between electric field and the area vector. So your cos theta is 180 now. So alpha a to the power half, this will be I cap. Electric field is directed along x axis only. So this will be I cap only. Surface area. Surface.
And would it be negative I cap?
What?
Won't it be negative I cap?
Electric field is directed towards the x-axis only, no? Positive x-axis. So electric field direction won't change. Electric field is directed to the this positive x-axis for the whole question. For all the faces, it will be towards the positive x-axis only. Okay. Regarding the surface area, you will be taking it as minus I cap. Here it won't be I cap, it will be minus I cap. A square, not I cap. Why? Because the area vector is now directed towards the negative x-axis. Electric field, positive x-axis, area vector, negative x-axis. So now your surface area is A square minus I cap. So now the net resultant flux, this will be E L dot SL. Means the dot product of these quantities. EL dot SL. So what is EL? EL you have as alpha a to the power half I cap dot multiplied with what? This is alpha a to the power half I cap. This is your electric field multiplied by the surface area. This gives you A square minus I cap. So you will be having minus alpha a to the power 3 by 2. This will be, this is minus I cap. So electric field multiplied by what? This is electric field multiplied by the surface area. You have it for the left hand side face. So total flux will be what? Total flux will be the sum of all the faces. Means net flux. This is phi right plus phi left plus phi top plus phi bottom plus phi front plus phi back, all the electric flux. See, electric flux for top, bottom, front, back, this is 0. So your net flux, the net flux will be the sum of electric flux for right hand side plus electric flux for left hand side. This came out to be, let's check, for left hand side. For right hand side, it was alpha root 2 a to the power 3 by 2. Alpha root 2 a to the power 3 by 2. And for the left hand side, it came out to be minus alpha a to the power 3 by 2.
Take alpha a 3 by 2 as common.
Yes, we can take 3 by 2 as common. So if you take, you can take alpha also common, you can take alpha a to the power 3 by 2 as common, you will be left with root 2 minus 1. All right. So you can put the values of root 2 as 1.4 and then subtract 1. So that will be 0.4 only, approximately. See, root 2 is what? 1.41. If you subtract 1 from it, that will be 0.4. So this will be 0.4 alpha a to the power 3 by 2. Some here like this, somewhat like this, because, or you can expand the values of root 2, 1.41, you can take it. So it will be 0.4 alpha to the power a by a to the power 3 by 2. So this was for the first part. We have taken flux for the left hand side, for the right hand side, for top, bottom, front, back. We had seen for the rest of the faces, since it was making an angle of 90 degree, it came out to be 0. Now it will be for only left and right faces. Now see, we have to calculate the charge enclosed. So what is the value of electric flux? Electric flux is Q divided by epsilon naught. We have seen what is flux. So charge enclosed will be what? Flux multiplied by epsilon naught. Flux is what? 0.4 alpha a to the power 3 by 2 multiplied by epsilon naught. This gives you the charge enclosed. Clear?
Yes, ma'am.
To all of you.
Yes.
Yes, ma'am.
Okay, just now note down these parts quickly. Shravya, you have copied it down. What are you saying?
Yes, ma'am. I made a note of all these.
All right, so if you have noted it down, this is the last question of today. You can leave.
Thank you, ma'am.
Thank you, teacher.
Okay.
Thank you, teacher.
Ma'am, and the second one, flux is equal to Q.
Which one? This for the left hand phase.
Yes, and the second one down.
Net fluxes for the left hand phase it came out to be minus alpha a to the power 3 by 2.
No, ma'am, can you go down?
This one?
More.
See, for the right hand side phase, it was alpha root 2 to the power a to the power 3 by 2 minus alpha to the power 3 by 2. From the right hand phase and from the left hand phase. So we had just taken alpha a to the power 3 by 2 common.
So in net flux, we took like in the top you wrote for the right, left, and then you wrote for 4 more. So what are the rest for?
CC. Is it clear how did we get flux for the right hand side phase?
Yes,
This one. This is clear? through the calculation electric field multiplied by the surface area. See, for the left hand side face, we calculated because of the direction changing, area vector and the electric field both were anti-parallel to each other. The area, the unit vector for the surface area came out to be minus I cap, because n cap is directed towards the negative axis now. So that's why we got minus alpha a to the power 3 by 2. All right. So is it clear till here?
Yes, ma'am.
Okay. Now see, when we take the net flux means all the flux from all the surfaces, means this left surface, this right surface, the top surface that we have, the bottom surface, the surface front, back, all the surfaces for this cube. Now see, for rest of the surfaces, we had seen that electric field and area vector were perpendicular to each other. So electric flux was 0 for all the faces. So which faces will contribute to the electric flux? Only the left and right phase, no? So see, the sum of electric flux from all these faces will give us the net flux. So for the bottom, for the front, for back, for the top face, these were 0. All these came out to be 0. So resultant will be given through what? Flux through the right hand side and flux through the left hand side. So if you add them, this was alpha root 2a to the power 3 by 2, and this came out to be minus alpha to the power 3 by 2. So if you take alpha a to the power 3 by 2 common from both of them, only root 2 will be left from here and minus 1 only will be left from here. Root 2 is what? Root 2 is 1.4. So 1.4 minus 1 will give you 0.4 only. So that is how we got 0.4 alpha a to the power 3 by 2. Is it clear?
Yes, ma'am. And what is that written below after Q?
Oh, which one? This one?
Yeah, after Q. Flux is equal to Q and then
Okay. See, the net electric flux is what? Net electric flux is always given by charge enclosed by epsilon naught. So the second part of the question asked us to calculate what is the charge enclosed. So we have calculated the electric flux from the first part. Electric flux came out to be this. Epsilon naught, we know. So if we multiply electric flux with epsilon naught, we'll be able to get this. Only this is variable to us, no? Epsilon naught is a constant, 5, which is a variable, we have calculated it. So if we multiply this quantity with this epsilon naught, we'll be getting the